Hi, today is December 30th, 2024, and this is the first video of a new series, Introduction to R Programming. To keep each video relatively short, I will only cover a couple of topics in each video. Today, we will only talk about R variables and operators in R. So R has symbolic variables, which are names that can be used to represent values. For example, we can assign the value 6 to a variable x. We can use this expression. So in particular, this operator is the assignment operator, less than and hyphen. So it's like an arrow. We assign the value 6 to the variable x, and immediately we can type x and R will return the value of x. Alternatively, we can just use the equal sign. For example, y equals 3, then y is 3. We can also define new variables using existing variables. For example, we can define a new variable z, which is the sum of x and y. And then immediately we type z, we get a value of z, which is equal to 6 plus 3, which is 9. By the way, if we want to put two statements in one line, we need to use semicolon to separate them. There are some limitations about variable names. So a variable name must start with a letter and can be a combination of letters, digits, period, and underscore. One exception, it can actually start with period, but if it starts with a period, it cannot be followed by a digit. For example, .3b is not a valid variable name. Try to avoid naming a variable starting with period. And then a variable name cannot start with an underscore. And variable names are case sensitive. So in general, R is case sensitive. So for example, age, lowercase h, and capitalized H, these are three different names. And there are some reserved words in R that we should avoid when we name variables. For example, logical values, true, false. And null, this is a reserved name to denote an empty list. And if else, these are keywords in a conditional statement, and some other things that we should try to avoid. For example, C is a function we can use to create vectors. Now let's talk about operators in R. So there are basically four types of operators: arithmetic, logical, relational, and some other operators. First, arithmetic operators, basic ones, plus, minus, multiplication, division, and power. And there are some special operators, for example, modulo, which will calculate the remainder. For example, if we calculate 1 plus 2 times 3 minus 6 divided by 2, we get 4. And then 10 modulo 3 is 1, because when 10 is divided by 3, the remainder is 1. So R can be used as a calculator. Second group, relational operators or comparison operators. They are quite familiar for us: less than or equal to, greater than or equal to, and equal to. So pay attention to this. So we need to use double equal to denote equal to for relational operators, and not equal to is denoted in this way. Let's see some examples. We can compare single values. A is equal to -5, B is equal to 2. Then if you want to check if A is less than B or not, just type it. We get true because A is indeed less than 2. How about comparing two vectors? So suppose V1 is a vector of three different types of values: true, 0.1, and apple. This is a character value. And then V2 is 0, 0.1, and bat. By the way, C is used to create a vector. C means concatenate. We will talk about it in the next video. And then if we want to compare V1 and V2, R will do the comparison element-wise. Basically, it will compare the first element of V1 with the first element of V2. Okay. So how to compare true with a number? So in R, true is equivalent to the number 1, and false is equivalent to 0. So that's why we got false. The first logical value we get is false. And then 0.1 and 0.1, they are equal. So 0.1 is not less than 0.1. So we get false for the second value. Then how about character strings? Apple and bat. Character strings are ordered alphabetically. A is lower than B alphabetically. That's why apple is less than bat. So we get true in the third value. So when we compare two vectors, the comparison is done element-wise. Next group, logical operators. The first group is element-wise logical operators, and, or not. So you can either use the letter and, or you can use the operator and, or a vertical bar. Okay, not, we use this exclamation mark. Okay. So for example, let's define two vectors. V1 is true and true. V2 is true and false. Then let's check V1 and V2. Logical AND. R will combine the logical values element-wise again. So first combine the first element of V1, true, and the first element of V2, which is true. So true and true, of course, is true. And then combine true and false, the second elements of the two vectors. So true and false will yield a false. Because for logical AND, only the combination of two true will yield a true. So that's why it's called element-wise logical AND. It will combine the two vectors of logical values element-wise. So similarly, element-wise logical OR works element-wise. For example, V1 or V2. So true or true, true. True or false, true. And lastly, not V1. So V1 is true and true. So not V1 returns false and false. Next subgroup, logical operators, double AND and double OR. So let's first try to combine two vectors of logical values together using logical AND, double AND. Turns out that we get an error. And so you see length equals 2 in coercion to logical 1. So this one won't work. So now let's combine two logical statements together. 3 is less than 5, true. -1 is greater than -5, true. So true and true yields a true. So this double AND can only combine two single logical values. It cannot combine two vectors of logical values. Similarly, logical OR, double bar, it can only combine two single logical values. 3 is greater than 5, false. -1 is greater than -5, true. False or true will yield a true. Some other operators. First, membership operator, in, percent in percent. This operator checks if element of one object is in another object. Let's see, x is a single value 5, v is a vector, true 5 apple, and if we check x is a member of v or not, we get true, because 5 is indeed a member of v. What if the first object is also a vector? Let's see. Y is a vector, false, and 5, and V stays the same. Then if we check Y is in V or not, it will check each element and see if it is in V or not. So the first element of y is false. False apparently is not in V, so we get false. And then 5 is in V, so we get true. So this membership operator works element-wise. It will check each element in the first object and see if it is a member of the second object. And another special operator is matrix product operator. Percent, multiplication, percent. So let's see. We define a matrix, a 2x3 matrix called M, and then we transpose it, call it MT. So MT is a 3x2 matrix. Then if we multiply M and MT together, we should use this operator. In the third video, we'll talk about how to create matrices and other data structures in R. But for now, we can just use the function. And this operator not only works for a matrix and the transpose matrix of it, it can be used to multiply any two matrices as long as their dimensions match. So for example, we can define an identity matrix I, a 3x3 identity matrix, and then we can multiply M by I because M is 2x3 and I is 3x3, so we can multiply them together. Alright, that's all for this video. In the next video, we will talk about data types and vectors in R. Thanks for watching. See you next time.